To all my viewers, feel most welcome into our today's discussion, whereby we are going to discuss about finding the Laplace transform using the first shift theorem. When it comes to the first shift theorem, the basic thing that we need to understand is that you can be given the Laplace transform of exponential at with respect to our function f of t, whereby the most important thing, we must first get the Laplace transform of our function f of t, and then to the term of s we come and do our shifting, whereby on this side we are going to have f into s we subtract from a. This is the kind of form that it will always take. We first find the Laplace transform of our function f, and then to the term of s we do our shifting. When we are having here a positive or a negative on this side, when we are having here a positive on this side, we must first have to the term that will be shifted, we are going to have a negative. And when we are having a negative at this point, after carrying out the Laplace transform of the function f of t, to the other side we must, on the term of s, we are now going to have a positive. Once you've understood those concepts, you are good to go. Let us now come here into our first example, whereby we've been told to find the Laplace transform using the first shift theorem of our function here. The first thing that we need to do is that we come and open the bracket, and we are going to have 3 exponential negative 2t sine hyperbolic 2t. We come and subtract from 6 exponential negative 2t cos hyperbolic 2t. Let us now find the Laplace transform of sine hyperbolic 2t, because we first get the Laplace transform of our function f of t, and then to the term of s we do our shifting. When we come here, we understand that the Laplace transform of sine hyperbolic at is equals to, because these ones we've derived them from the first principle formula. Here we understand we are going to have a all over s squared. We come and subtract from a squared. And now here we are being told to find the Laplace transform of sine hyperbolic 2t, to mean that we are going to have 2, because 2 is equals to a s squared. We come and subtract from 2 squared, which is equals to 4. But we've agreed that when it comes to the first shift theorem, we must first get the Laplace transform of our function here, and then to the term of s, we do our shifting, because that is what the first shift theorem require us to do, to mean that we are going to have 2 all over s. Now, to our signs here, we are having a negative of 2, a negative of 2. And we say that when we are having a negative of 2, to the term of s will be now be a positive, because negative goes here with the negative. Negative at this point goes when we've done our shifting, here it becomes a positive. To mean that here we are having a negative of 2. So here we are going to shift with respect to a positive of 2, everything squared. We come and now subtract from 4. Everything we multiply by 3. We subtract from 6. The Laplace transform of cos hyperbolic at is equals to s all over s squared. We subtract from a squared, to mean that when we are having the Laplace transform of cos hyperbolic 2t, we are going to have s all over s squared we subtract from 2 squared, which is equals to 4. Let us now do our shifting here, because we first gotten the Laplace transform of our function f of t. Now to the term of s, let us now do our shifting, to mean that we are now going to have s. Here we are having a negative of 2, so here we are going to shift with respect to a positive of 2 all over s. Here we add to 2, and this is what we refer to as shifting. We come and subtract from 4. On our numerator here, now we can come and work out our bracket. On the numerator now we are going to have 6 all over s we add to 2 squared, we come and subtract from 4. We subtract from here, we are going to have 6. We subtract 6s, we subtract from 12 all over. On our denominator we are going to have s we add to 2 squared, we come and subtract from 4. Since we are having a common denominator, now we are going to have 6, we subtract from 6x, we subtract from 12 all over s we add to 2, everything squared, we come and add to 4. At this point we can simplify both the numerator and the denominator. By simplification of our numerator, we are going to have the constant numbers together, and now we are going to have negative 6. We come and subtract from 6, because here we are having a positive and here we are having a negative of 12 all over. Here we are going, when we open our bracket here, we are going to have s squared, s we multiply by s multiplied by 2, and then we multiply by 2, we are going to have 4s. We come and add to 4. And here, sorry, this one is supposed to be a subtraction from this point. And here we come and subtract from 4. Here now we are going to have, in our next step now we are going to have negative 6 into s, we add to 1. That is from our numerator. Here we have a common term of 6 and a negative all over. On our denominator, these two are going to cancel out, and we are going to have s squared, we add to 4s. And this is how you go about finding the Laplace transform of our function here using the first shift theorem. Our today's session, whereby we are still going to discuss about finding the Laplace transform using the first shift theorem. And when it comes to the first shift theorem, the first thing that we need to understand in a function like this one is that we must first open the bracket using the exponential outside the bracket. And by opening the bracket, we are going to have 2 exponential t cos 3t. We come and subtract from 6, 2 multiplied by 3. We are going to have 6 exponential t sine 3t. Up to this point now, we can now start using the first shift theorem. And when it comes to a function like this, the first thing that we need to understand is that we must first get the Laplace transform of cos 3t. We understand that cos at is equals to s all over a squared we add to a squared from the first principle. To mean that when it comes to our function here, cos 3t, we are going to have s all over a squared, we come and add to a squared. But our a is equals to 3, so we are going to have 3 squared. Now we want to do our shifting on our term on this side, whereby when we are doing the shifting, it is only the term of s that is being shifted, to mean that we are going to have 2 into the term of s will be shifted this way. When you check here, our exponential, the coefficient of the exponential is equals to a positive of 1, because we are having here t, so it is a positive of 1. And when it comes to shifting, now we are going to have s, we subtract from 1, because here we are having a positive of 1, all over the term of s will be shifted. Now we are going to have s, we subtract from 1, everything will be squared, we come and add to 9 because of 3 squared. Now let us get into this side. We are going to have, we subtract from 6 exponential t sine 3t. We understand that the Laplace transform of sine at from the formulas that we deduced previously, here we are going to have a all over a squared we add to a squared. Let us now come here. We are going to have our term of a will be 3 all over a squared, we come and add to 3 squared, because 3 is the term of a. Let us now come and do our shifting to the term of s. To mean we are going to have, we subtract from 6 into 3 will retain its position, and we are going to have s here on the denominator. Here we are having a coefficient of positive of 1. Here we are going to have a subtraction of 1. Everything squared we come and add to 3 squared. Let us now work out our functions here, and by working out our function, here we are going to have 2s we subtract from 1 all over s we subtract from 1, everything squared we come and add to 9. On this side we are going to have a subtraction of 18 all over s we subtract from 1, everything squared we come and add to 9. From this point now we can come and here we are supposed to be having 2, because we take 2, we multiply by this 2, then we multiply by that, so you are supposed to be having 2. We come and now simplify the two fractions, whereby we are going to have, when we check here on the denominator, we have a common denominator, so we are just going to have as we subtract from 1 on the denominator, we come and add to 9. On the numerator, we are going to have 2 as we subtract from 2, we subtract from 18. To mean that we are now going to have, on the numerator, we are going to have 2 as we subtract from 20. Everything all over. We come and open our bracket here on the denominator. And by opening the bracket, this one is equals to s we subtract from 1, we come and multiply by s we subtract from 1, because it is s squared, of which we are going to have s squared, we subtract from 2s, we come and add to 1, we add to 9. To mean that our final answer, we are going to have 2 into s. On the numerator, we subtract from 10 all over On the denominator, we are going to have s squared. We subtract from 2s, we add to 10 as our answer. And this is how you go about finding the first shift theorem of a function like this one.